Okay, so first one, hopefully no one will get these wrong.
7.7.
Right, if you give the diameter, the radius is half.
55. We need a label on those.
No.
50.
Okay? If you know the radius, the diameter is double. 2.25, right? Okay.
All
right.
This is just like the test, right?
Yep.
Okay.
Okay, then the matching.
So we're gonna have matching on the test?
Yep.
No.
Point of tangency is just a point where a line touches a circle. So there's actually there, 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 and there. There's 4 points of tangencies. They have got C.
But it's actually E.
Yeah. C is a point of tangency. So is D, but it's not a choice. So is H, and so is E, but they're not choices. The center, you got two choices. It's either A or B.
H.
Right there. A diameter, there is only one diameter. HF. C. A chord. This one you got more than one choice. GD is a chord, and a chord is a segment. So GD.
It doesn't
Now,
have arrows?
no, a chord is a segment. Now, this one you could put, because technically a diameter is a chord also. So you could put C here because HF is also a chord. So either one of these would be
But
true
it
then.
says F doesn't have arrows at the end.
No, neither does a chord. A chord is a segment. A chord starts at a point and stops at a point. From there to there, that's a chord DG.
Oh, okay.
I'll just repeat what he said.
So this is chord HF.
So then
Now,
You just hear what
a secant is a line. So right there, line DG, right there. See, it's got the line. So the secant is a line that cuts through. Common internal tangent, internal goes inside. So that'd be this line, which is CH. That's A. Common external is outside, so that's DE.
I switch them around.
And in a radius you've got, it could be either this one, this one, this one, or this one. B, A, D.
Internal.
Internal goes in between them.
Internal.
External's outside of
Okay.
them. Okay? Everyone got those? All right, this is just like on the worksheet. Before you solve them, just fill in everything you know. This is half a circle, so subtract these two off of 180. That would be a 38. These two are vertical, so that's 52. And this would be 128, right, because this is half a circle, so just subtract that off. So, arc ET, remember 2 letters is the shortest route, so that'd be 52. Arc SF, 38. TSF. Now this is technically kind of an error, because when you have 3 letters, it's supposed to be a major arc. But anyway, you do what they tell you. TSF is these two together, 128.
Good job, Brady.
Angle EMU, 128. Now this has happened in the past, and it wouldn't be wrong if you did it, because you can use this angle, EMU, this way, which would be, subtract that off of 360. So, you know, technically, you could put 232 degrees. That would be this angle here.
What,
Right.
angle M isn't that though. Angle M is 128. Not.
Well, it could be this angle from here to here. You know, if you got an angle, you know, we usually measure the short way, but you could measure around the long way too.
Okay.
Yep. In real world problems we don't, but technically that's correct. So angle SMU is 90. again, technically, you could put 270 and it'd be correct. An angle EMS
142.
would be from here to here, 142.
Wow. Or
Or you could do whatever that is off of 360. Okay, now on this, you're finding either angle LMN or arc LN. So, here, this is 182, so this is 90, right? 91, sorry, yeah.
Yeah, sorry.
This is 50, so LN is 100.
Zip it.
65.
This is 130, so this is 65. 165.
330.
Now, this is the trick one.
It's angle.
That
L
isn't
and-
arc LN. LN is the shortest route, so actually they want from here to here. So it's 30 degrees is the correct answer.
Dude.
Wouldn't that be for 19 then?
So,
Huh?
Or is it?
No, because since we know they're looking for the actual angle there. So yeah, I know there is one similar to this on the test. Make sure,
Well, why isn't that LMN?
because whenever there's two letters, you take the shortest route.
Yeah, but you already found LMN. It's 165.
yeah.
Because it says
330.
angle of the circle LMN.
Right.
Or
Arc.
yours.
This arc is 330. Now arc LN is two letters, so that's the shortest route. So arc LN is from here to here. That's what they actually want.
Maybe I
Yeah, but it says or. Or.
That's-
It says you don't have to find LMN.
But on the front page, we could go along with it.
Yeah, but on the front page, they weren't telling you which one to find. This one, when it's designated two letters, it's the shortest route. So remember that. There is no angle, or we already know angle LMN right there, so that's why you don't find angle LMN. You already know it.
Unknown one.
Yep.
Okay.
Okay, when it's a tangent and a chord, the angle is half of the arc. So AB would be 104. This would be 108, half of the arc. This would be 90, because since that's a diameter, that means this is 180 degrees, right? So the angle would be half. Here's the one like on the worksheet. To find it inside, you add them up and divide by 2. So it's 119, but they're not looking for that angle. They're looking for that angle. So the answer is 61. When it's outside, you subtract them and divide by 2. So we got to figure out what this is. So you just subtract those off of 360.
Gotcha, Emma.
So this is 26. So it's 160 minus 26 divided by 2. 67. Okay. Now here you just got to kind of know your rules. This is the key right here. This is a diameter because it shows the center. So since this is 150, this is 30, right? So then when the angle's inside, you add 30 plus 84, and then divide by 2.
You already found angle 1 though. What?
No!
So this is 57 degrees. If this were a central angle, remember, then it's the same as the arc, but it's not a central angle.
Okay.
I think that's what you were thinking of, is when we found that's 30,
Oh yeah, sure.
but it's not a central angle.
Oh yeah, because I'm the
Yep.
diameter. Okay.
Okay, it's outside, so you gotta subtract these two and divide by 2. So figure that out. Subtract them off of 360. And this is 80. So it'd be 106 minus 80 divided by 2 is 13, right? 26, yeah.
Small includes.
Then it's the segment lengths. So it's the outside times the entire piece equals the outside times the entire piece, which is x plus 8. So 100 equals 8x plus 64. So then you just solve it. Subtract 64, divide by 8, and that's 4.5, right?
Yes.
Oops. Same thing here, it's the outside times the entire length equals the outside times the entire length, which is 4 plus 3x.
I'm not handing them.
So again, we get 100 equals 16 plus 12x. So subtract 16, divide by 12, and you get 7.
That's 31.
That's 31.
How do I get 100? 100 equals 4.
It's 10 times itself.
Wait, the whole thing is 3x.
The whole thing is 4 plus 3x.
Why didn't they tell me that? Why didn't they just tell me that?
Okay, when it's inside now, it's the piece times the piece equals the piece times the piece. Now, remember, what is 3x times 3x?
9x squared.
9x squared. Some people just put 9x, or sometimes 6x. So this is 144. So we divide by 9. And then you got to square root to get rid of the square. Okay, this one's just like these. It's the outside piece times the entire length, which is 2 plus x, equals the outside piece times the entire length, which is 8. So that'd be 4 plus 2x equals 24. So we subtract 4 divided by 2. X is 10.
Yay.
Then it's just the circle ones, just like the ones we just corrected. Here, it's just backwards. They give you the equation, so all you got to do is give the center. So what's the center? -3. Right, remember it's the opposite of those. And the radius is 7. Because remember, this stands for r squared. So you got to square root it. So this one, the center is -2, +6. Now, if this is not a perfect square, just leave it like that. Square root of 38.
What if I do that though? Like, what if I
If you put the decimal, that's fine.
Okay, it was 6.2.
Yep, that sounds right.